the next part for this question 5. Okay, question 5b is testing you on similar area and similar ratio. Okay, so the first thing you should realize is they talk about similar, and they kind of give you the volume ratio. So you should be thinking about the generic formula. So you should be thinking about the volume ratio formula and the area ratio formula. And if you think about these two formula, you should realize that they are related by the length ratio. So they are related by the length ratio. Okay, so what am I given here? So I'm given the volume of A, volume of B, and the volume of C. So the volume is 1, 3, 8. Okay, so I'm supposed to find the height of cone A, the ratio. I'm not supposed to find the actual height. I'm just asked to find the ratio. So you are not given the actual volume. So you need to take note. So you are not given the actual volume. The actual volume is not 1 unit. The actual volume is not 1. Okay, it's just that when they are put into this ratio, then it's 1:3:8. So 1:3:8 is not the actual volume. It's just the volume ratio. So if I would like to get the height of the cone A and height of cone C, essentially I'm supposed to find LA is to LC. So it should come from the volume ratio. So it should come from the volume ratio. So I will pick these two ratio. So I'll pick these two ratio, knowing that the volume ratio is actually the length ratio with a cube. So from here, I can cube root. And that's how I get half. Okay, so I'm just playing around with the formula. Okay, subsequently, we wanted the surface area of cone B as a percentage of the surface area of cone C. So essentially, it's something like this. You want the area of B over the area of C times 100%. So this is what the question is asking you. So in order, remember I said that the two ratios are actually linked by the length ratio. So I'm going to make use of the volume ratio first. So I'm going to make use of the volume ratio. I'm going to make use of B, the volume of B, and then the volume of C. So I'm going to make use of the volume of B and the volume of C first, so that I can find my length ratio. So after I can, then with the length ratio, I can apply it to find my area ratio. So it will be this ratio with a square. Then from there, I convert to a percentage. So the two formulas are related by the length ratio. So I make use of the volume ratio to get the length ratio, and subsequently from the length ratio, I can find the area ratio. So it's just switching around. So it's actually quite easy to switch around. Okay, just read carefully.